A clear mountain road can disappear into fog within minutes, not because the ground suddenly turns cold, but because the wind is lifting moist air up the terrain. This is upslope fog, a cloud sitting on the ground along hills, escarpments and mountain passes. The key process is orographic lifting. That simply means air is forced to rise when it meets rising land, like the windward side of a range. As the air climbs, the pressure around it falls. The air expands, and that expansion makes its temperature drop. This is called adiabatic cooling. For dry air, the cooling rate is about 9.8 degrees Celsius per kilometre, or roughly 3 degrees per 1,000 feet. As the temperature falls, the air can hold less water vapour. Its relative humidity rises even if no extra moisture is added. When the air cools to its dew point, it reaches saturation. At that point, water vapour condenses into tiny droplets, and if those droplets are at ground level, you get fog. The height where that first condensation begins is called the lifting condensation level, or LCL. If the LCL is low enough to touch the slope, fog can spread across the road, ridges and passes. If the LCL sits higher, the same process may produce a low cloud base above the terrain instead. Upslope fog needs three main ingredients: low-level moisture, steady wind blowing into the slope, and a stable atmosphere. Stability matters because it keeps the air layered and smooth. If the air is too unstable, rising motion is more likely to build showers or deeper cloud, rather than a broad sheet of fog hugging the hillside. In Australia, the Great Dividing Range is a classic setup. Moist easterly or onshore winds can be pushed up the eastern slopes, cooling as they rise. That is why mountain districts can go from clear to fog-bound quickly, especially when moisture has built up overnight near the surface. The Blue Mountains west of Sydney are a good example. Steep slopes and high ground can trap humid air on the windward side when onshore flow lines up with the terrain. Similar upslope fog can also form on other escarpments, including the Darling Scarp in Western Australia, when moist air is driven uphill. Upslope fog is different from radiation fog. Radiation fog usually forms on clear, calm nights when the ground loses heat and cools the air just above it. Upslope fog does not need calm conditions. It relies on moving air, terrain lifting and cooling during the climb. Forecasters look for wind direction, moisture, terrain exposure, cloud base height and stability. A humid wind on a map is not enough. It has to hit the slope at the right angle, rise far enough and reach saturation before crossing the ridge. For drivers, the risk is practical and immediate. Visibility can drop below 1 kilometre and sometimes much less over a short distance. Slow down before entering fog, switch to low-beam headlights, leave extra space, and avoid sudden braking. If visibility collapses, only pull over where it is safe and legal. The simple rule is this: when moist, stable air is pushed uphill, cooling can turn invisible water vapour into a ground-level cloud. On Australian ranges and escarpments, that process can make familiar roads look completely different in just a few bends.